Hello, geometry folks, and welcome to Area of Triangles, Parallelograms, and Rectangles. We are going to begin to understand area and use area formulas and figure out how they apply to different shapes. So the shapes that we're going to focus on today are triangles, parallelograms, and rectangles. You are going to need your calculator, a pen, and a pencil because you will be making some markings. And that'll be good for you to have a pen or a highlighter, and then your notes and your formula sheet so you can begin writing down various areas on that formula sheet. All right, here we go. So what is area? Well, area is the space inside a shape. It's measured in square units. Now, let's back up a minute. We've talked about area before and we've talked about perimeter, but I want to focus on perimeter for a second. Perimeter is figuring out how many feet you would go around this whole arrow, okay? And so if I wanted a distance all the way around and we were talking about perimeter, we would be talking about a length, okay? So centimeters, feet, inches, etc. But when I'm talking about area, more specifically, I'm talking about the space inside. So how many square units fit inside the shape? So area is measured in square units, so feet squared, inches squared, centimeters squared, etc. So you want to be really careful and make sure that when you're working with these formulas that you're using the proper units. If you're finding area, it needs to be squared units. If you're finding a length, then you want them to be just in whatever measurement that we're finding, so centimeters or feet. Okay, so make sure that you know the difference in those units. Okay, so let's go ahead and talk about a few areas that you're going to put on your formula sheet, and you probably already know these. Okay, so here's a square. The area of a square is base times height. But what we know about a square is that all the sides are the same. So if all the sides are the same, I can really say area is side times side. And side times side is side squared. So this is the formula that you could use for a square, knowing that all the sides are the same. Area of a rectangle. The area of a rectangle is the base times its height. Okay, now you've used length times width, and that's totally fine when we're talking about a rectangle, but I want you to get away from the whole idea of length times width, because when we talk about a parallelogram, you can't say length times width. So base times height is the best way to remember the area of a rectangle. Because now I have the area of a parallelogram. And if I want to find out the area of a parallelogram, what I could do is I could take part of the parallelogram off and move it to the other side. And when I do that, I have base times height. Okay, let me show you that one more time. So parallelogram, this is a parallelogram because all sides are parallel. Okay, but if I take part of that parallelogram off and put it to the other side, it now looks like a rectangle. So now the area of a parallelogram is the same as a rectangle. Base times height. Okay, but I truly want you to get away from using the terms length times width, because when we have a parallelogram, the width is not what we're going to use. We want to make sure that we use the height. It's really important that we know the height, okay? So that's area of a parallelogram. An area of a triangle. Well, if we take a quadrilateral and we cut it in half, okay, then we have a we have a triangle. So excuse me, so half of a parallelogram or half of a quadrilateral would be a triangle. So the area of a triangle is base times height divided by 2. And that's one that we've talked about a lot in the past year. So you probably know these formulas, but we just want to make sure that you get them down on your formula sheet because we're going to be talking about a lot more area formulas than these basic ones. All right, so now let's go ahead and work with these formulas by giving us different shapes. So I want you to find the area of the shaded region. So if you were going to identify what kind of triangle or what kind of shape that shaded figure is, what would you say? Well, I kind of see a triangle here, and then I kind of see this, but this doesn't really make sense. So maybe if you look at the whole figure, if you look at the whole thing to me looks like a parallelogram. And the area of a parallelogram is base times height. So if I were going to look at this, the area of this parallelogram, I would need the base. Well, the base in this case would be 6. Now what's the height? This is where you have to be really careful and not say it's 12, because the height of this parallelogram is not 12. A height is an altitude that drops down to make a 90-degree angle. So the height is actually, to get from this 12 to this part here, is 8. The height is actually 8. Okay, so 6 times 8 would be 48. Now we're talking about an area, and our units for area have to be units squared. Okay, if we were talking about centimeters, we'd say centimeters squared. If we were talking about feet, we'd say feet squared. Now make sure that you don't write 48 squared, because that is not the same as 48 units squared. That is a very important part. Now that's one way, but maybe some of you can see it a different way. Okay, so let's look at it another way. Say you don't like the way this figure is positioned on the piece of paper, so you decide that you want to draw it this way. Okay, so here's my parallelogram. This is 6, this is 12. Oh, and looky here, we've got this thing dropping to make a 90, and there's a little 4. So say we wanted to find the area of the parallelogram the way it looks now. Well, it's still going to be base times height. The base is 12 because in a parallelogram, the opposite sides are congruent, so the base is 12. But this time, the height is 4. Now we should get the same answer. 12 times 4 is, you got it, 48 units squared. So maybe you have a figure, but you want to find it a different way. There's lots of ways to find the answer. Maybe you just need to redraw it so it makes more sense to you. Okay. So now let's do another example. Now what if I give you the area and I want you to find a length? So the area of a triangle has an area of 126 centimeters squared and a height of 14 centimeters. What is the length of the base? Well, area is equal to base times height divided by 2. The height is 14. The base is what we're looking for. So I'm going to put 14 in for the height, divided by 2, and I know the area is 126. So now I've got to use some algebra to get b alone. So the opposite of dividing would be multiplying. So I'm going to multiply both sides by 2. 2 times 126 is 252. That's equal to 14 times b, so 14b. The opposite of multiplication is division. And divide both sides by 14, and I get the base is equal to 18. Now, is that 18 centimeters squared or 18 centimeters? Well, the area was squared, and now I'm looking for a length, and the length would be centimeters alone. So the base would be 18 centimeters. All right. Here is another application. We are trying to find how many pounds of grass seed should you buy to cover a lawn. A pound of bluegrass seed covers 1,650 square feet. Now, area is one of the most widely applied ideas of geometry. It's really one of the most widely used ever. And if you don't think you will, you just might find out later on in life that area is used a lot, especially when you have to seed a lawn or mow a lawn or, cover a certain part of your bedroom floor or the walls because you have to paint. So making sure that you really understand area is really important. So we've got this problem, and we want to find the area of this whole figure. Now this figure is kind of crazy looking, so we need to develop a plan. So my plan that I came up with by looking at this figure, because I have no idea what the figure is, but I can see that there's different figures within the whole thing. Like I can see there's a triangle here, and there's a parallelogram here, and another triangle here. So because I can see all these different figures, I've decided that I am going to find the area of the right triangle, and then I'm going to add that to the area of my parallelogram, and then I'm going to add that to the area of the other triangle. Okay, so what is the area of a triangle? Base times height divided by 2. The area of a parallelogram is base times height, and the area of another triangle would be base times height divided by 2. Okay, so let's look at the right triangle. I'm going to redraw it so it looks like this, so I can see it upside right. So this is 20, this is 52. Now, what do you remember about right triangles? Can you find the third side? Yes, we can by the Pythagorean theorem. So 20 squared plus x squared is equal to 52 squared, because this is the hypotenuse. All right, so 20 squared is 400. X squared equals 52 squared. 52 squared is 2704. Subtract 400. I get 2304. Square root both sides, and x equals 48. So that height is 48. Okay, so area of the base is base times height divided by 2. Base is 20 times the height, which is 48, divided by 2. 20 times 48 divided by 2 is 480 feet squared. So I have the area of that triangle, because that was the base and this was the height. Now I'm going to be looking at the area of the parallelogram. So I want to look at the parallelogram. Okay, so base, well, the base is 80 because opposite sides are congruent, times the height. Now remember, the height of the parallelogram is not 52. The height is where you can drop down and make a 90-degree angle. So hopefully you can see that if this is 48, that this would also be 48. So the area of the parallelogram is 80 times 48, which is 3840, 3,840 feet squared. Now we need an area of the other triangle. So now we're going to be looking at this triangle, okay? And the area of a triangle is base. Well, the base looks like 40. And the height is not 52. The height is where I drop down a 90-degree angle. And I could do the Pythagorean theorem because I have a right angle now. So this would be 20, that would be 52. But that's already this guy over here. So this height is also 48. So 40 times 48 divided by 2, which would give me 960 feet squared. Now if I add all these up, my total area, is 5,280 feet squared, or square feet. Okay, now that tells me the area of this whole figure. But now it says, we make sure we read the directions again. A pound covers 1650, so 1,650 square feet. So how many pounds of grass seed should I buy? Well, that does not tell me, 5280 does not tell me how many pounds of grass seed I should buy. So to find out how many pounds I buy, I would take 5280 divided by 1650, and because every pound will cover 1,650 square feet, and that gives me 3.2 pounds. So I should buy approximately 3.2 pounds of seed. Okay, so you have to make sure that you go back and answer any questions that also might be being asked in these problems. Thank you for taking good notes, and area is not too bad as long as you can come up with a plan and separate all the figures to find the complete figure. All right, we'll be beginning to work on this again tomorrow.